In this lesson, we'll talk about compound interest. Compound interest is a fairly common practice, in which when you are collecting interest, you are collecting interest on the interest that you collected before. It sounds a little bit complicated, but the formulas work out kind of nicely. This is basically the concept of interest paid on interest. It simply means that each time we compound interest, we have a new principal from the interest added on in the previous month. Let's take a look at this example. Suppose we've got an account compounded yearly at 8%, and we want to find the balance of the principal of $1,000 after 3 years. So what we're going to do is we're going to have $1,000 is my starting principal. And I'm going to take 1 plus the rate, which is 0.08, times the time. Let's just do 1 year and see what we get. I get $1,080. That's the first year. For the second year, again, we're compounding interest on interest. So we've got the 1,080 that we're going to be compounding in the same manner. So we're going to get 8% interest on the $1,080 from the first year. When I do that, I get $1,166.40. That's the amount in the second year. And then finally in the third year, we're going to start with the $1,166.40, and we'll again compound 8% interest onto that. I get $1,259, and I'll round this to 71 cents. This is my third year. So at the end of 3 years, I have $1,259.71 based on this compound interest. Let's take a look at what this would have been with simple interest. Had we done the usual simple interest formula, we would have had the starting amount of $1,000. 1 plus and R is 0.08, but this time we're just going to do all 3 years simple interest. I get $1,240. As you can see, doing this compounded, where interest was compounded on interest, does make a little bit more money. Now this process looked a little bit complicated. You can imagine if I were to do this for many time periods, this would take a long time to do all those calculations. Fortunately, there's a formula that gives us this value. This formula is similar to the one I've been using for simple interest in that it doesn't just give us the interest but the final value after this time period. And we can make it a little bit more complicated than just a yearly compounding. We can compound as many times per year as we want. So here's your compound interest formula. You've got some principal. It might be a savings or it might be a balance against you. And if that principal is growing with an interest rate of R, we get this formula that tells us the balance if we compound n times per year for t years. So let's give this a try and see what we can get. So we've got Dana investing in a special account at her bank that gives 4.5% interest, and they compound monthly. We want to figure out how much is in her account after 4 years. So let's write down a few things. P is the $3,000. R is the 0.045 interest rate. N is the number of compoundings per year. So the problem said that it was compounded monthly. Well, how many months are in a year? 12. T is the number of years, and there's 4 years in this problem. So let's write out the formula. A equals 3,000. Then you've got 1 plus the interest rate divided by 12 to the NT. Now putting this in your calculator is something to try to use caution. Sometimes you can make some mistakes here if you're not careful. When I do this calculation, I get approximately $3,590.44. So that is the amount in the account after 4 years. Now how much interest was earned? Well, we don't really have a formula to find the interest. However, I think it's pretty obvious in this problem. What you can do is you can take the amount that we had after these 4 years and subtract off the amount that we had at the beginning. That gives us the interest earned is $590.44. Let's do a comparison with what we just did. If we do various amounts of compounding, we might find that the answers are a little bit different. Annually. The difference for this one is that n equals 1 time per year. So if I use the formula, I have 3,000 is my principal, 1 plus the interest rate, but this time I'm just going to divide by 1 to the 1 times t is 4. So this is annual compounding, 1 time per year instead of 12 times per year. I get $3,577.56, which is not quite as much as we got on the previous slide. How about semi-annually? Semi-annually is 2 times per year. We'll use the same formula, and you'll notice this time I've put in n equals 2 instead of 1. This time, I get approximately $3,584.49. Still not quite as much as when I did monthly, but more than when I do it yearly. Let's do quarterly. Quarterly means every quarter, and as you might expect, the word quarter is 4 times per year. So we would say n equals 4 this time. Let's plug this into the formula again. You'll notice this time I've used n equals 4 in this problem. This time, I get approximately $3,588.04. You'll notice that this value is getting very close to monthly, but is still a little bit less. However, it is more than annually or semi-annually. Now let's look at daily. Daily would mean 365 compoundings per year. That's quite a number of compoundings, but this is actually somewhat common. Let's plug that in the formula. Now this time I'm using n equals 365, so this calculation probably looks a little bit harder than it did last time. If you need to, go ahead and multiply the 365 times 4 in advance, just so it's easier to plug into your calculator. I get approximately $3,591.61. So it seems that I have finally managed to get higher than monthly. The moral of the story here is the more times per year that you compound, the more money you can make. However, that doesn't mean that it's going to be a drastic change in the amount of money that you make. Let's look at the reverse of this type of problem. So suppose we want to take a trip to Tahiti in 5 years, and we're going to need $5,000 in that 5 years. What we're going to do is we're going to set some money aside now and figure out how much money we should deposit so that after these 5 years we will have the $5,000 that we want. We'll assume that we have a 6% account that's compounded quarterly. So let me just write out the whole formula. So remember, it's A equals P times 1 plus R over N to the NT. And we don't have exactly the same setup as we usually do. This time I'm actually given A. A is 5,000. P is unknown this time. R is my 0.06, and we're going to be compounding quarterly. So quarterly is 4 times per year. 4 times per year again, and the number of years is 5. This one looks a little bit different. And so what I'm going to do is, instead of trying to calculate all of this out, I'm just going to go ahead and divide both sides. So what I did was I just divided by this entire coefficient on the P, and I did write the 4 times 5 is 20, but this makes it so that I can put this in my calculator in one step. Here's what I get. I get P equals 5,000 divided by this part of the compound interest formula that we usually see multiplied by P. If I put this in my calculator, I get $3,712.35 needed, so that in 6 years the money would rise to 5,000. Be careful when you do problems like this and read them carefully. Make sure that you can tell the difference between if they're asking for a future value or if they're giving you the future value and asking for the value that needs to go in now. Let's finish off this lesson with the concept of inflation. Inflation is a big deal as you look back into the history of this country and really the history of the world. The cost of something has slowly risen as time has gone by, and this is what we call inflation. It's the idea of how much a dollar can buy nowadays versus how much a dollar could buy in the past. The formula that we usually use for inflation is this one, that is really just the same as the compound interest formula, but with n equals 1. So let's see if we can calculate this. Suppose that you're making $21,600 a year, and you receive a cost of living raise each year. That simply means the raise has the same percent as inflation. Let's find out how much this $21,600 becomes in 15 years. So we've got A equals the $21,600 is your P, R is 0.04, and T is going to be 15 years. I get approximately $38,900.38. That's a lot more money than you were making 15 years before. Or is it? Unfortunately, with inflation, what this means is that you're making $38,900 a year, but you won't be able to buy any more with that $38,000 than you could with the $21,000 15 years before. The price of everything has gone up at the same time.